Hello and welcome to Chem 315 Nuclear and Radio Chemistry 1. This is Unit 5 and we'll be looking at detection and measurement of radiations. In the first session of this unit, we'll be looking at measurement of radiations. And this session would introduce you to the background of the device mechanisms that can accurately measure the radioactivity and its effects. By the end of this session, you should be able to give simple introduction to the background of accurate measurement of radioactivity. You should also be able to describe the idea behind the device mechanism of measurement of radioactivity. Let us begin with measurement of radiations. As we discussed earlier on, radioactive decays are accompanied by the emission of radiations. And so there is the need for us to devise mechanisms that can help us to accurately measure the radioactivity and its effects. These measurements will be done qualitatively and quantitatively. Qualitatively, then we are looking at which kind of radiations are available, and quantitatively we are looking at what is the amount of these radiations that are available. The radiations that are emitted by these radioactive materials are measured on the basis of absorbed dose and exposure. The exposure here refers to the radiation that is incidented upon an object, and the absorbed dose refers to the actual interaction of that radiation with the object. There are various types of equipments that are employed in the measurement of radioactivity, and each makes use of different principles. Each has its limitation, which account for preference for others. Let's look at the absorbed dose. The absorbed dose can be measured in terms of the energy delivered per volume. So what amount of energy is delivered by this radioactive radiation per unit volume. Then also the energy delivered per volume. We can also measure it in terms of ion pairs created per volume and also ion pairs created per mass. In order to understand the measurement of radiation, let's recall the units of radioactivity we learned in the past. So the becquerel is one of the units for measuring radioactivity, and 1 becquerel is equal to 1 decay per second. Also the curie is one of them, and 1 curie equals 37 gigabecquerel. The gray is another unit for measuring radioactivity. The gray is actually a unit of absorbed dose of ionizing radiation. Now, when the density of the total energy absorbed in any medium from any type of ionization radiation is 1 joule per kilogram, we say that refers to 1 gray dose. So the dose of 1 gray should be equivalent to 1 joule per kilogram. Also the rad is another unit, and it's a unit of absorbed dose of ionization radiation. So 1 rad is equivalent to 10 milligray. The dose can be expected to vary from one point to another within the irradiated object. In order for us to be able to measure the radioactive radiations, the primary ionization of the radioactive element must always be preserved. We must not lose it to recombination or scavenging by electronegative atoms. Also, we need to amplify certain electrical signals before we can observe them. And so electronic instruments play very important role in modern day nuclear chemistry. Let's look at performance of any detector type. So common criteria that are used to evaluate the performance of any detector. In order for us to measure the radiations, we need to first of all be able to detect them. And so it's very important for us to know how we can evaluate the performance of these detectors. One of the ways is the sensitivity of the detector. The big question we ask ourselves is, what kind of radiations would the detector detect? Once we know which kind of radiations it can detect, then we know what kind of radioactive decays we must use that particular detector for. We must also look at the energy resolution of the detector. So the question we ask ourselves is that, would the detector be able to measure the energy of these radioactive radiations that are striking it? And if so, would it be able to precisely measure these radiations? We must also look at how much radiations these detectors can measure without any error. So that is what we basically have in the third point. And then in the fourth point, we must look at the detector efficiency. With the detector efficiency, what we are looking at is that if we have, for example, 100 rays striking the detector, exactly how many would it be able to detect? So these are some common criteria that are used to evaluate the performance of any detector type. Let us look at radiation dosimetry. Now, radiation dosimetry is any technique that can be used to measure radiation rather than just detecting its presence, as we use the Geiger-Müller to do. So the dosimetry will help us to be able to detect the presence of these radiations and also to measure them. The question we may ask ourselves is, why the need to measure these radioactive radiations? Or why do we have to measure these radiation doses? There are a variety of situations that call for this measurement, and we have grouped them into two main classes. The first one is the personnel monitoring. The personnel monitoring is intended to help protect individuals who work with these radioactive materials or radiations producing machineries. So this personnel monitoring is basically for those who work with these radioactive producing machineries. It tends to protect them. Also, another situation that called for the measurement of radiation dose is site monitoring. So this also helps to protect workers and passerbys who might be exposed to these radiations from a particular source or from a specific source. Let us look at the importance of dosimeters. So radiation dosimeters, they are used so as to provide measurement of dose over a specific time interval. Example of these radiation dosimeters is the monthly film badges, and it is typically used to detect lapses in techniques or broken equipment that over a period of time will produce excessive exposure. The film badges, for example, are typically much more sensitive to radiations from the front than from the back because the plastic holders and clips absorb radiation and they will be calibrated for direct exposure. So it is very important that workers will understand the limitations of these dosimeters because incorrect positioning of these dosimeters could lead to falsely low reading. These are your assessment questions which I want you to go through them